Okay, so having done the CAL, we'll start with SML. SML, you know, is a exhibit of the CAPM, capital asset pricing model. And the first step here is to calculate beta. Beta by formula statistically, you know, is the covariance between the security and the market by variance in the market. So first I'll take the mean returns for both Nifty as well as the stock here. And you see that the mean return is equal for both Nifty as well as the stock. So xi minus x bar, so that is your deviations in the market, right? And I will repeat that for all the years. Same way for deviations for the stock. It will be each individual return minus the mean return. And I will repeat that for all the years. Next step to get the covariance. Formula for covariance is sigma xi minus x bar into yi minus y bar by n minus 1. So you take the multiple of the deviations, which is deviations of the market and the stock. And then you should get the covariance between the stock and the market, which is summation of these multiples by n minus 1. So that gives you 0.00040. Then you have the variance in the market. For variance in the market, we will take the square of the deviations for the market. So take each deviation of the market and square it up. Do that for all. And that should give you your variance in the market, which is the summation of the square deviations around the mean, divide by n minus 1, which is 0.00150. Once you have this, you can get the beta, which is the covariance between the stock and the market by variance in the market, which comes out to be 0.26667. So now that you have it, you can get the expected return using the CAPM model, which will be risk-free rate of return given to you in the question as 6% government security yield plus beta times the market risk premium, which is the average return that Nifty gives you minus 6%. So you get the expected return to be 9.47%. So if I take the beta as an input here, I will take this beta as the input here. So this is my input. And the expected return I can take as my output. Okay, independent variable and dependent variable. So I put my independent variable here and the expected return using CAPM as a dependent variable. So this is my independent variable. This is my dependent variable. And I try to plot starting from 0, 0.1 and go up to maybe 1.5. This is your base case. And now we can find out the expected return using the CAPM model. If I use the data table technique, I can use this as my column input cell. the beta input and find out what is the I just need to link it to this one. So if I link it to this one here, I should get all my returns. Right? So this, what does it plot? This plots your systematic risk of beta on the x-axis and the expected return on the y-axis, right? If I now take if I want to draw a chart here, I can. So Nietzsche, you will see on the x-axis the various levels of beta, and on the y-axis you see the returns, and this becomes your security market line. Now, if you look at carefully at the security market line, the security market line cuts the y-axis at what point? It cuts the y-axis at 6%, which is your intercept. That means the lowest level of return that you can earn is your risk-free rate of return. And that's why RF is your intercept. And the slope of the, if you want to find out the slope of the capital security market line, we can use the slope function. Take the known y's, which are your returns, and the known x's, which are your betas. What do you get as the slope? You get the slope as, what is this? This is your slope of 13%, which is nothing but RM minus RF. RM is 19%, RF is 6%. So 19 minus 6, 13% is your slope. Which therefore mean, and what about the intercept? Yeah, you don't need to do it. It's right here. This is your intercept. When there is no beta, you will still have a 6% return. So therefore, it tells you that for the SML, security market line, the equation of the SML is therefore the CAPM model, capital asset pricing model. The slope of the SML is your market risk premium, which we just saw. The intercept is your risk-free rate of return. Now, please remember, one of the applications of the security market line is that it helps you with intrinsic valuation of the security. So that means if you use the cost of equity, which you get from the CAPM, to find out the price of the securities, intrinsic value of the securities by discounting all the cash flows to the present, that's the price that you will be willing to pay to the security. It will get you to the intrinsic valuation or fair value of the security. Now, what happens? Suppose there is a security which is below the SML. So let's say I put here, yahan pe. So a security that plots, please look at the chart, a security that plots below the SML. What does it mean? It means that it is giving you the return which is lower than what your intrinsic valuation gives you, which is on SML. When do you get a return which is lower? Overvalued. When you actually buy a security at a higher price, then only you'll get a lower return, no? Whereas if a security that is plotting above the SML, That means it is giving you a higher return, and that can only be possible when you're buying a security at a lower price. So any security that plots above the SML is said to be undervalued. Any security that plots below the SML is said to be overvalued. And any security that plots on the SML is said to be fairly valued, which is the most crucial and fundamental aspect of the security market. Okay, thank you.